Okay, so this is again the worksheet. For each one of these, right, we want to state the domain, the range, and whether the relation is a function or not, okay? So the domain, remember, is just the x coordinates, right? So I'm using the curly brace, although I'm trying to draw it. You want to, in curly braces, you just want to list the x coordinates, you know, the first coordinates, that is, because that's what the domain is. So we have 1, right? We have 2, and we have 3, as you can see. And for the range, it's really the same idea, except now you list the y coordinates. So for the range, we have the y coordinates, which in this case is going to be 5, comma, 12, comma, 20. And again, notice I'm separating them by a comma and using curly braces. Now, is this a function? Well, the answer is yes. And why is it a function? Because the ordered pairs all have different x coordinates. They all have different x coordinates, okay? You know what, for fun, let me draw the correspondence diagram. Okay. See if it comes out well. Oh boy. See, I don't know if that's gonna work. Okay. So again, we have 1, see if I can make this work, 2, 3, good, everyone can see that. Here we have 5, 12, and 20. You know, I did say if it's a function, say so. If it's not, explain why. So again, if you're going to draw the correspondence diagram, you just draw arrows, right? So the first one, 1, comma 5, you just draw an arrow from 1 to 5. Like so, that's all. Okay. That's just indicating that 1 is assigned to 5. 2 to 12, same idea. Right? 2 is assigned to 12. And finally, 3 to 20. Okay? Again, same idea. 3 is assigned to 20. I mean, this is another way to see that it's not really an explanation, but you can see it's a function because you have only one arrow coming out of each diagram. Excuse me, sorry, coming out of each number. Okay? I'll do the others. Are there any questions on that? And hopefully it made sense. I think it did. Okay, let me move up. Wait, let me move down just a little bit. I just renumbered it because for some reason 1 did not appear up there. I just added it though. Just do this. All right, here we go. So for this one, it's the same idea, right? Same idea. What's the domain? Well, you're going to list all the x coordinates. So you're going to have 5. You're not going to list 5 more than once, okay? Because remember, in a set, there's no repetition. So we have 5, that's listed. 5's already listed, but we do have 10, and we have 15. Okay. Now for the range, it's the y coordinates, right? That's why. So we have 9, we have 10, we have 7. Oh wait, not done yet. We have 100. Almost forgot to write down 100. Okay, so that's what we get here. So that's the domain and range. Now, is this a function? Well, the answer is no, right? And why is that? Well, that's since we have 5 and 9 and, oh boy, see if I can make this work. 5 and 9 and 5 and 10 are in the relation. So in other words, 5 would be assigned, okay, 5 would be assigned then, okay, to 9 and 10, which is impossible. Okay, so for a function that can't happen. So this is which cannot happen for a function. Oh boy. Always run out of room. So I always have so much to write. Oh, that's okay. Okay. Okay, so now that's what we have here. Okay, so let me just move this up for everyone. Actually, what I'm going to do here, I'm just going to change the things a bit. I'm going to write it down here below it because I have more room down here. Okay, so this is the domain. You know, I'm running out of room. So, okay, so the domain for this one, right? The domain for this, well, again, it's all the x coordinates, right? So what do we have? We're going to have 2, 12, 4, 7. Right? That's the domain of this relation. For the range, what would the range be? Well, it's all the y coordinates. So in this case, the range would be 8, 100, 2, and 8. Actually, well, I made a mistake. What mistake did I make? I can't list a number more than once. So I'm just going to erase that, like so. But now, is this a function? Well, it turns out the answer is yes. This is yes. The relation is a function. Oh, wait, they can't see that. The relation is, in fact, a function. It is a function, okay? I mean, you can see that by looking at the, the ordered pairs, right? You know, all the ordered pairs have different x coordinates. They all have different x coordinates, right? So that's why it's a function. Okay. Let me draw a correspondence diagram for the second one here. I mean, again, you didn't have to, it wasn't part of the worksheet, but let me just do it just for fun. And I'll draw one for the third one I won't, but for the second one, let me draw one. Let me draw it. Okay. So we have 5, 10, 15. There we go. Just separate. Then for the other set, we have 9, 10, 7, and 100. 9, 10, 7, and 100. There we go. Okay, so here we can draw the correspondence diagram. So 5 is going to go to 9, right? Because we have that ordered pair. 5, 9 is there. 5, 10 is also in there. So we draw an arrow from 5 to 10 as well. I mean, right away, you can see it's not going to be a function as well, right? Because 5, as I wrote down, 5 is assigned to more than one number. In a function, each element, each number from the first set can only be assigned to one element from the second set. Okay, that's what has to happen in a function, right? You have 9 and 10 both have 5 assigned to them. They both have 5 assigned to them. 10 is assigned to 7, and 15 is assigned to 100. Okay, you know, that's just a correspondence diagram. Nothing too fancy, but I figured it'd be good to draw it. Do you have any questions about this? I know my handwriting's not the best, so sorry about that. Okay. Just move down a bit. Again, we have this one. This is for the third one. So I didn't draw a correspondence diagram, but we didn't have to. Okay. All right, let me now get to the lecture notes. So I'm going to stop the recording